So today we're going to be talking about areas of parallelograms and triangles. And the first thing we need to talk about is parallelograms. So any side of a parallelogram can be called the base, but the height specifically has to be a perpendicular distance between two parallel bases. If you remember, a parallelogram means that opposite sides are parallel. So this little triangle shows those are parallel and those are parallel. So a straight line, top to bottom, connecting those bases at a right angle, that's what makes it perpendicular. We'll make that the height, and then again we can just call that top side the base. So our first postulate for chapter 11 is postulate 11.1, the area addition postulate, and it states that the area of a region is the sum of the areas of its non-overlapping parts. So if you can add up the areas together, that would give you the area of the total shape. So the first thing we're going to be doing in this chapter is finding the area of a parallelogram as well as the perimeter of a parallelogram. So for perimeter, we can just add up all the sides, but for the area, we have this formula here, which is just area equals base times height. And remember, height being what we talked about up here, that straight perpendicular height. Okay, so for our first example, we're finding the perimeter and area, and I have a parallelogram drawn here, and it's not perfectly drawn to scale because I just used one of mine that I could trace, but right here we have this 9 yards and then the full is 17. So again, I know this doesn't make sense because I didn't draw it the best, but that means that this rest of this piece right there is that 8 yards, because together those would be 17. If you remember from our 45-degree triangles though, that the two sides would be the same. So this would be 9 yards. And then we can use Pythagorean theorem or SOHCAHTOA, but we can use Pythagorean theorem to find the slanted side. And we need the slanted side to find the perimeter. So we would do 9 squared plus 9 squared equals c squared. 9 squared is 81. 81 plus 81 is 162. So 162 equals c squared. Take the square root. And we get 12 and we're just going to do 12.7. We don't need to do too many decimal places. So 12.7 equals C. So that means that this side is 12.7 yards, and so is this side. So for perimeter, we're going to add 12.7 plus 12.7 plus 17 plus 17. So we have 12.7 plus 12.7 plus 17 plus 17, and we get 59.4 yards. So the perimeter is 59.4 yards. And then for the area, we do base times height. Well, the base is the 17 times the height is 9. So we do 17 times 9, and we get 153. So the area is 153 yards square. So perimeter is going to have just yards for its unit, and area will have yards squared. Okay, so for our next example, we won't have to deal with angles, but you could do like we did on those angles anytime. But what we're going to do instead is we're going to work if we don't know all of the sides again, but we just don't have the angles. So what we do know is that if this is 23 feet, this is 23 feet. And then again, because that's a right angle, we could use Pythagorean theorem. So we could do 7 squared plus 24 squared equals c squared. 7 squared is 49. 24 squared is 576. We'll add those together and get 625. And then take the square root. And we get that slanted side is 25. So that means that this is 25 feet and this is 25 feet. So then again, our job is to find perimeter and area. So for perimeter, we're going to add up 23, 23, 25, 25. So our perimeter, I think that's 96. Yep, is 96 feet. Again, just feet. We do single units for perimeter. And then for area, base times height, the base is 23 the straight height is 24. This is that straight height that connects the two bases. So do 23 times 24. And we get 552. And that will be feet squared. So our perimeter is 96 feet and our area is 552 feet squared. So for a triangle now, again, the base can be any side, and then the height is just the length of the altitude drawn to a given base. So remember, altitude goes from an angle and it goes across the opposite side at a right angle. So this straight at a perpendicular 90-degree angle will be the height, and then the base will be the opposite side from that height. So our second postulate for our chapter is postulate 11.2, the area congruence postulate, and it just states that if two figures are congruent, then they have the same area. So that we're able to solve for the area of a triangle, we have a new formula for that. So area is just base times height, but you divide by 2. It's also fine if you want to do half base times height. Either way would work. Okay, so now we have a triangle, which is right here. It says 19, 41, and we don't know the third side of it. And then we're given the rest of this dashed lines to help us see that that would be the right angle. And again, this would be our height. So we're going to find the perimeter and the area. So for perimeter, we have to know this missing side. So again, because it's a right triangle, we can do Pythagorean theorem. So we have 27 squared plus 30 squared equals c squared. So 27 squared is 729. 30 squared should be 900. We're going to add those together and get 1629 equals c squared. Take the square root and get 40 point, and we'll just say 40.4. We can do one decimal place. So 40.4 equals C. Okay, so now we can find perimeter and area. So perimeter equals 19 plus 41 plus 40.4. 19 plus 41 plus 40.4. We get 100.4. And that will be inches. And then for area, we do base times height. So our base is the 19, our height is the 30, and then we divide by 2. So that will be 19 times 30 divided by 2. So 19 times 30, 570, divided by 2, 285. So area is 285 inches squared. So our perimeter is 100.4 inches and our area is 285 inches squared. Okay, so on our next one, we have a triangle right here that has 29 centimeters as its base, and we don't know the height or the third side, but we do have this information over here, and we're going to use, again, Pythagorean theorem to find this missing side, and then, since this is a right angle, this would be a right angle, and we could do Pythagorean theorem again. So we have 6 centimeters, so 6 squared plus that height squared, we'll call that b, equals 13 squared. So 6 squared is 36. Plus b squared equals 13 squared. That should be 169. We're going to subtract 36. And we get b squared equals 133. Take the square root. We get 11.5 rounded. So this is 11.5 centimeters. So that's going to be our height and one of our 3 sides of our triangle. So we still need the third side to find perimeter. So we will do 29 squared plus 11.5 squared equals c squared. Now one thing to note here is 11.5 squared was that 133. Sorry, I kind of cut y'all off there. So we can go ahead, I like to just keep whatever it was. It's fine to go ahead and square it again. It'll just be a decimal. So I'm going to go ahead and put 133 there since I know that's what it was. But then 29 squared is 841. And we'll add 133 and get 974 equals c squared. Take the square root and get 31.2. So this one is 31.2 centimeters. So for perimeter, we're going to be adding 29 plus 11.5 plus 31.2. So 29 plus 11.5 plus 31.2. We get 71.7. So perimeter is 71.7 centimeters. And then for area, we do base times height. So our base is 29, our height is 11.5, and then we divide it by 2. So area will equal 29 times 11.5, and then divide that by 2. And we get 166.75. And we'll just leave it with 2 decimal places since it rounded itself. That will be centimeters squared. So our perimeter is 71.7 centimeters and our area is 166.75 centimeters squared. Now, if you did not round like I did here, just going back to 133, if you squared this, you might be a little bit off in that 31.2. So if we're off a little bit, like by 1 decimal place here or here because of that choice, that's okay. I'm gonna be lenient on your decimals. Just make sure you're showing your work so that I can see where you rounded, and then I won't take off. Okay, so for our last example, we're just gonna be working backwards. So we're gonna have the area already, and then we'll have one of the parts, we won't know the whole part. So this is a parallelogram. So that means our area formula is base times height. Area is 148. The base is 8, and the height, we don't know, is what x is. So we would divide by 8. So we have 148 divided by 8, and that's 18.5. So x equals 18.5 meters. And then we have a triangle here. So we do the same thing. Our triangle formula is base times height divided by 2. So we already know the area is 357. The base is 34. The height, we don't know, it's x divided by 2. So you have 2 options here. You can go ahead and multiply by 2, or you can reduce this. I would probably reduce, but you could do it either way, because I just know that 34 divided by 2 is 17, and then I'll divide by 17. It will get you the same answer no matter which way you do it, so do which way makes most sense to you. But 357 divided by 17 is 21, so x equals 21 inches. So that's how you would work backwards from the area to find one of the missing measures.